Okay, in our next example, once again, we're going to find the equation of the tangent line for the function f of x equal to 5 square root of x at the ordered pair 1, 5. Again, we're going to need to get a slope and a point on the line. Let's start by finding the general slope. That is our limit definition, and that's going to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And I can kind of do a little split here. They gave us that f of x was equal to 5 square root of x, and the only other thing we need is f of x plus h, because remember, as I told you, the only things you're going to be inputting into this equation is your f of x plus h and your f of x. So let's see if we can't figure out what f of x plus h is. And that just is simple function notation that says come up here and take my f of x, and everywhere there's an x, let's make it an x plus h. So this is going to be equal to 5 square root of x plus h. Get my pen here, sorry about that. There we go. All right, so let's go ahead and put these things in, and we get that f prime of x then is going to be equal to the limit as h approaches 0, f of x plus h is 5 square root of x plus h minus my f of x, which is 5 square root of x all over h. And of course, if we try to do a direct substitution on this, we're going to get 0 over 0, totally not allowed. We can factor a 5 out of the top, but that's really not going to help us a whole bunch because I'm still going to have 0 divided by 0. But I do notice that I have something here that lends itself to using a conjugate. Now again, if you want to factor out that 5, you can do that. Matter of fact, you can bring it all the way out in front of the limit. It does make things easier if you choose to do that. If you don't want to do it, that's fine. We can do it without. We can leave it just as it is and multiply using the conjugate, which is 5 square root of x plus h plus 5 square root of x. And remember, you always must do it by itself, since we can only multiply by 1. Now, we never want to go ahead and multiply the things that aren't conjugates, so the bottom of this we're going to leave it alone, but we do want to go ahead and multiply the top. So the bottom we're just going to leave just exactly as it sits. Now on the top we're actually going to multiply it out. When we multiply 5 square root of x plus h times 5 square root of x plus h, we actually get 25 times x plus h. The reason being 5 times 5 is 25, and the square root of x plus h times the square root of x plus h is x plus h. The outer and the inner will cancel. That always happens when you're dealing with a conjugate. And when we multiply the last, we get a negative 25 times x. Again, 5 times 5 is 25, and the square root of x times the square root of x is equal to x. Now we need to go ahead and do some cleanup on this top so we can see what we have. And this becomes the limit as h approaches 0 of 25x plus 25h minus 25x, all divided by h, times 5 square root of x plus h plus 5 square root of x. Here, this 25x and this 25x are going to go away, and I'll write this in one more step. Again, the number of steps you do before you do your direct substitution is up to you, but I need to see something. You can't just start trying to substitute indirectly. I'm going to write this out as 25h divided by h, again, times 5 square root of x plus h plus 5 square root of x. Again, this will give me 0 over 0, but if I go ahead and cancel out those h's there, I think I'm going to be in good shape. And now I will do my direct substitution. This is going to give me 25 divided by 5 square root of x plus 0 plus 5 square root of x. And then, of course, and I'm going to have to go sideways here because I'm running out of room on my page, this is going to give me 25 divided by 5 square root of x plus 5 square root of x. And 5 square root of x and 5 square root of x is 10 square root of x, so I get 25 divided by 10 square root of x. And then on this part, 5 goes in there twice, goes in there 5 times, so that my final answer here is going to be 5 divided by 2 square root of x. Now, let's see what that does in terms of what we were doing here. what we had was our function f of x was equal to 5 square root of x, and we wanted to write the equation of the tangent line at the ordered pair 1 comma 5. Well, we find using the limit definition that the derivative is 5 divided by 2 square root of x. And remember, what this represents is a general slope. We are asked to write the equation of the tangent line. And once again, I need you to remember that there are two things that you're going to need. You're going to need that specific slope, and you're going to need a point. Once again, they give us the point. The point they give us is the ordered pair 1, 5. Now, in order to get the specific slope from the general slope, all I need to do is pick a value of x, and I'm going to use the one they give me. So I'm going to evaluate f prime at 1. That's going to be equal to 5 divided by 2 square root of 1. Now, you never use the plus or minus of a square root unless you're taking the square root of both sides. So we get 5/2 for our slope. This, folks, is going to be our m value. And then the x1, y1 was given to us. Again, the formula that we're using is y minus y1 is equal to m times x minus x1. So putting in everything but x and y, we get y minus 5 will be equal to 5/2 times x minus 1. And we get y is equal to 5/2 x minus 5/2 plus 5, moving that 5 over to the other side, and then cleaning up that fraction, we get 5/2 x. That's going to give me negative 5/2 plus 10/2 is going to give me a positive 5/2. So the slope of the tangent line is going to be 5/2 x plus 5 over 2. A couple things to point out here. You're always going to write your equations as y equals, so you will have to deal with the fractions, but we can do that. The other thing is, if I come back up here, and let me highlight it so you can see it, and look at my general slope. Remember that I have mentioned to you before that if we get something like the square root of x in the denominator, like we have here, we don't actually rationalize this because we don't know what x is going to be. So we don't rationalize this denominator. And as we saw in the case of what we got, we didn't need to because we could get the square root of 1. Now, if you can't take the square root of whatever's down there, that's the case where you would rationalize that denominator.